So, want to welcome everybody. Today we are going to be discussing the critical 5 of landscape lighting installation. Obviously many of you are brand new getting into landscape lighting, and so as you're starting to learn about the primer, some of the basics about landscape lighting, I'm going to take you through just 30 years of experience with me doing landscape lighting, running landscape lighting businesses. There's some do's and don'ts, and there's some efficiencies, right? If you've got a business, you really need to know how to run and operate a landscape lighting business efficiently. And there's probably going to be some similarities to the AV business and the CI business that you're doing now. So we'll look at some of those, but I'll move through it. So just to give you a little bit about background about me, I was a landscape architect. That's the way I got started. Fell in love with lighting 25 years ago, and have been doing it ever since. Currently sitting on the board of directors for 2 of the leading outdoor lighting organizations that train and empower people wanting to learn more about landscape lighting. 2 organizations, the Association of Outdoor Lighting Professionals and the International Landscape Lighting Institute. If you want to get into lighting, I'd recommend you go to especially ILLI. That'll teach you how to see and understand landscape light and apply it to your designs. And AOLP really helps you with the business of outdoor lighting and training your techs on installation. So those are great. I'm also an IES Technical Committee member for landscape lighting. So been doing it a long time, and I'm all about education, so which is why we're here today. So I'm hoping that we're going to be able to help you learn a little bit more, put a few more tools in your toolbox, and help you, empower you to be better at landscape lighting as you get those opportunities. So today we're going to take a look at some of the basics, a lighting system anatomy. And this is landscape lighting 101. So some of you may be familiar with this already. And if it's a rehash of what you already know, that's all right, just ignore it, we'll move on. But we're going to look at a lighting system anatomy and the installation process. Power systems, controls, voltage management, infrastructure cables, connections and hardware, fixture types, placing and aiming, system documentation, the final details. Everything you need to kind of go through an entire installation. So the first thing we're going to take a look at here is the anatomy of a landscape lighting system. And I look at lighting as you have certain components in a landscape lighting system. Can everybody hear me okay? All right, perfect. And think of it like a circulatory system of a body. You have the power system, your transformer as being your heart that's pumping all the energy through the system. Obviously the blood, that's going to be your amperage, your current, that's your energy moving through. Your brain is obviously your controls, so whether you're talking about custom integrated controls or just dummy controls, it's basically controlling the on-off of the light. I liken all the cables, all the circuitry that runs throughout the landscape. That's your circulatory system. Your valves are your connections, and the extremities, the things that do the work for you, are going to be your luminaires, your fixtures, and your lamps, LED sources. So real basic how all those things work together. And what we're really going to discuss today a lot is about being efficient with landscape lighting. Knowing the ins and outs, how to do landscape lighting installation correctly is going to help you make more money. Some of the key really, it comes down to efficiency. Sorry, I'm tracking back over myself here. So you can see kind of a little bit here, some of the things we're going to talk about here in the next few minutes. When you get out to a job site, what size teams do you need? What activities and duties should they be doing? How to split those loads up so that as you're working on that job site together, you're working in tandem on relevant activities that work together so that at the end of the day, you're winding up at the same place together. I have found that 2-man crews are probably the most efficient for mid-sized installations, anything between 35, 50. Hey, how you doing again? 35 to 50 is always a good place to start with 2-man crew. If you need more, you can always work a 3rd man in, but as you're getting started, a 2-man crew is a good way to go. You start with a lead tech and start with a helper tech. Your lead tech's going to do more of your advanced installation work. But every installation, every job you go out and do, and it's probably very much this way in the AV space with you guys, is every project begins with a good on-site pre-construction meeting before you get started. And really what you should be doing, working with the designer out there, making sure you're covering the entire scope of the project, what types of fixtures are going in, where the wires are going, right? You got to discuss, hey, we're going to come around these bushes, these trees are going to come around the house. You need to talk about your power center locations, whether it's going to be in a house or it's going to be on an external wall, where the power is, the line voltage power is coming from, how it's being controlled. There's special site considerations and concerns, how we're getting under sidewalks, how we're getting under driveways, obstacles that might be in your paths. Those things need to be discussed. Always good to remind your clients about site cleanliness. Don't have guys who are just leaving trash everywhere. Pick up immediately after yourselves. Clients notice that stuff. Should be in uniforms. Everybody have everything tucked in, clean, looking together. Don't smoke on site. I mean, you guys can do what you want, but I say don't smoke on site. No loud music. Put in some earbuds if you have to, right? Just professional decorum for your business. We always have those talks with our site. And then you need to actually have that information about the clients, making sure their pets are inside, making sure they're aware of your activities when you're going to be done. And that's kind of a good way to start and have that pre-construction meeting. Beyond that, what we'll do now is I'll take my lead tech and I'll go out and I'll start flagging fixture locations. And on my flags itself, I want to write the type of fixture that's going to be there if it's a certain configuration, just so that there's no miscommunication. They can look at plans, but sometimes they might not know it exactly. And if you can put a flag in a particular spot, there's no question about where that fixture is going. And it may not be aiming it exactly the way you want it, but it's there. And that's a good starting place to put those things. So have your team go through, flag with your main guy and your lead tech, and flag it if you need to. It's always a good way to do it. Next thing you want to do is, now is when I start to split my team. It's now we've gone over, everything's flagged, and say, ready, break, let's go team. So in a two-man team, I have a team tech 1 and a tech 2. During the split, I have tech 1, who's my lead tech. He's always going to go through and he's going to install my transformer. He's going to unbox it, get all the controls out. If he's got to put TA, terminal adapters, lock nuts, conduit, he's got to put all that in there. He's going to take care of all that, getting that set, getting it where it needs to go. And he's just getting it all prepped. So one thing he's also going to do too is, and I'd recommend you guys, when you're out installing your lighting, you need to know what circuit it's going on, especially if you're not using a dedicated circuit for landscape lighting. You don't know what's on there. I've had times where we've plugged into a circuit, or had a tech plug into a circuit, and we thought, hey, this is good to go. And the customer comes in and they've got all these appliances in the garage, and it overloads the GFI, and it just keeps tripping the transformer because of an overload. So if you don't have a dedicated circuit, open the panel, find out what circuit that's on, ask the client, hey, are there any appliances here we need to turn on, and just test how much capacity we have. A good rule of thumb is don't overload the capacity. It's the 80-20 rule. Never go over 80% capacity. And you can start doing this with volt amps. You can, your VA factor, you can calculate how many what capacity you're going to need, or you can even just take true watts, whatever's listed on a fixture. If it's 7 watts, you can add the cumulative total of that, divide that by 120, get your amp load, and figure out what you're going to need. That way, you just want to make sure the circuits. If you got a 15 amp circuit breaker, you're going to have about 12 available amps. Again, in a 20 amp circuit, you're going to have about 16 available amps when you're using the 80-20 rule. So just know what you're going to be putting on that circuit ahead of time, and measure. You never want to go back. Transformer locations, it's always good. If you're going to put them on the outside of a wall, and again, you're not always going to be using advanced controls. Sometimes you're putting something out there, it's very simplistic, it's path lights. They don't always have to be on a Lutron system. Sometimes it's dusk to dawn, it needs to operate. So even for very dummy controls, locate a transformer in a place where it's easily accessible. Think about service. If you need to come back, which you will, come back and service that. Think about, does that client need to be home when it needs to be serviced? Sometimes it's an inconvenience for them. But if it can be on the outside wall where you can just schedule it, come out, service it, take care of it, God, they're not inconvenienced, it's locked away. I don't like to put power centers on the fronts of houses, just visually they don't look good. So if I have to, I'll move them to the side of a house and have the electrician move an outlet and bring power to the side of a house, just so we can conceal them. But be careful about where you're putting them. Don't put them under heavy tree cover if you're going to use a photocell, obviously, because you'll trip on sometimes if the sky gets dark. Or you can use an astronomic timer. So when you're installing transformers, the NEC requires you need to be 10 feet from water, and mounting at least 12 inches above ground level is where the bottom of that transformer needs to be. So those are just basic NEC codes for that. You have to watch. And one thing you'll notice, if you're placing a transformer close to where the inbound power is coming for a house near a panel, you have to be careful about inrush current, particularly if you're using, you have a lot on that transformer, if it's anything over like 600 watts you're using on that transformer, because what will happen is as power comes into that panel, as you kick those lights on, it's right there, right near the source, and sometimes it's that inrush flow, it can hit hard like a hammer and it'll trip those breakers because they're working on current activity. So sometimes you need a little bit of a slow ramp up of power to get to that transformer. When we put it away in a house, farther back in a house, it has time to work through the circuits of the house, get back to those outlets, and it's usually never a problem. It's just when that outlet is really, really close, right to the panel, and there's not a lot of distance between the main panel and that plug. Sometimes you can get inrush current. A way to easily fix that is, it's kind of a no-brainer fix, is add an extension cord to it and bury it in the ground and hook your light to it because it gives it 100 feet to run through and you'll take care of that inrush current. So that'll be something you'll see sometimes. John?
You mentioned that using the photo cell, too much shade is the problem. Another thing people need to look out for is neighbors, because some of these houses are really close together.
Yeah.
So too much light is also a problem.
That's true.
Some people can have security lights that are on all the time.
Yep.
Or even if they just come on,
they'll trip them.
Night,
Yep.
It will affect your light. So
great. John.
Not only shade, but light is a problem as well.
John's he's a certified outdoor lighting designer. He's been in this business a long time, so yeah, he definitely knows for sure. Definitely got to watch for ambient light elsewhere too. Also, when connecting the transformer, you need to make sure you're using an in-use cover because it's not a temporary use. You're going to be plugged in all the time. You always want to have it connected to a GFCI circuit. Either the outlet needs to be a GFCI or go back to your panel and put a GFCI outlet or GFCI breaker in your panel if you're going to control it by the circuit. So always an in-use cover. Put a drip loop always under. I've seen crazy stuff, guys, where we've had transformers mounted high and wire comes down right into an outlet and it's just a path for water from rain to go right in that outlet and go, why does it keep dripping? Well, I don't know why. Water does that. So a drip loop right up underneath, pretty common sense. It just keeps water out. But if you're using an in-use cover, it's going to force you to come up underneath there and do that anyway. Okay, so Tech 2, while Tech 1 is installing the transformer for efficiency, what I do is I break up Tech 2. His job is to start, if you haven't pre-assembled your fixtures, get them out there, open those boxes up, get all your fixtures pre-assembled, get them lamped or get the modules on, get the accessories on, lay them out in the grass. Good rule of thumb, if you haven't installed them, leave the plastic on, because as you put those things in the landscape, you're going to be working around them, you're going to bang them, they're going to get dirty, you're going to have to pick them up and move them with dirty hands. It makes for less cleanup later. So if you can leave a little bit of plastic on those bodies, it helps, or just plan to go and wipe them down at the end. But have your tech put those together, and sometimes your lead tech will get done with the transformer first, have them come back and help get the fixtures out. And then once the fixtures are laid out, your power center is all done, now you guys start opening trenches and we start pulling all together. I'll talk a little bit about where we place trenches. But now you guys want to start opening those trenches, and this is going to be the part that everybody hates. Nobody likes to dig, but yeah, it's not bad. It's not bad. We recommend, if you can, minimum cover. The NEC, it used to be minimum 6 inches of cover. Now with low voltage circuits, now they've gotten crazy where you can actually lay them on the ground and they don't care. But that is a terrible way to do it because you don't want to see cables laying around. So minimum 6 inches of cover, and stake them down with sawed turf staples in places, because what will happen is that iron, it'll start to build up, it'll rust, and it'll lock into the ground. You can't pull those staples up. And so especially in like Michigan and areas where you have freeze-thaw cycles, as you're going out and doing service contracts, you'll see that cable start to push up out of the ground if it's buried too shallow or it's not stapled down. So just take extra precautions, staple those things in as you're going along. Once everything's assembled, have your Tech 1, he's going to go start placing fixtures in elevated areas. So we'd always have a tech that's really comfortable in trees and ladders, and we'd have one guy maybe not so much. And so the guy that naturally wants to go up, he's going to start placing tree down lights. You might be placing stuff on the architecture on the second floor. And you break up that workload that way. The other guy's going to start putting things out into the field and breaking up that load. For the fixture installation, you always want to use an appropriate stake to match the size and weight of the fixture. I've seen great big fixtures have tiny little stakes, and it's just going to fall over and get knocked over. So if you have a robust fixture, use a robust stake or a trident stake. Plastic is always a great way to go because they're going to go a heavy-duty, I would say heavy-duty PVC stake, because it's going to be inert in the soil. It's not going to rust. So that's a great way to go. Certain brands, they have nice brass inserts, so it makes a really secure fit. Or go with a stainless steel trident stake. It's going to be a stainless steel platform, thick plate that has 3 stakes that go in the ground, and that's a real secure platform also. So just make sure you've got good stability. When we talk about grazing architecture, I usually like to be 18 to 24 inches off a wall, almost pointing straight up, because I'm going to be using the bottom side of my beam to pick up the soft wash on a wall in grazing. You get too far out, you're doing a wash effect, and it makes for a really flat light appearance. You want some texture. You want light and shadow to work together. So by bringing those fixtures in, not too close because you'll get hot spots, but about 18 to 24 is kind of a sweet spot. You got to work around with plant material that's planted the foundations, but work with that, and you're almost pointing straight up, catching the bottom of the beams. So that's kind of the sweet spot for that, and you can adjust at night. White walls are going to be way more sensitive than dark walls. White walls, you're going to see beam artifacts, you're going to see, optics are going to show in those, but dark colored walls, much more forgiving. So just keep that in mind. I give our techs tape measures. I say take a tape measure, go out, and you're going to measure off. Every single fixture is going to be exact, because if you notice, especially if you have little overhangs in your details in your architecture, if one is back even a couple inches more than the other, you're going to see it in the shadows, and the length of the shadows above it is going to be mismatched. So just make sure, tape measure everything, get it even all the way on your architecture. Try not to bury your knuckles too deep. Those are the joints where you're going to be able to move your spotlights. I like to leave at least a couple inches above the mulch where it goes, where you're burying that, because if you're burying at ground level, you're still going to pull your mulch back on at least a couple inches. So just be cognizant of that as you're putting it back in. And then even most important is, as you're burying your fixtures out in the landscape, remember the landscape is a dynamic space. It is never going to stay the same. From year 1 to year 3, even year 2, you need to remember that at some point you are going to have to move that fixture back as these trees grow, these plants grow. So having extra cable, sometimes some fixtures come with 25-foot leads. Use that extra lead, wrap it up, zip tie it, bury it in the ground right next to that stake. And then as you need to, when you have to come service that, you can just pull that up. Instead of having to cut and resplice, you can just pull some of that wire back and you can move your fixtures around. It makes it much easier. So just keeping that in mind. Tree fixture installations, the only thing you should ever put into a tree is stainless steel hardware. Never use anything else. As that tree, particularly, some trees have very thick bark, you're never going to get through it, but some are very narrow. And right underneath that bark, there's a green cambium layer where all the water, all the nutrients, everything goes through. And as you puncture that with anything but stainless steel, you're opening up that tree to react natively to even coated screws, coated deck screws, things like that. Steel screws are bad because they'll rust, and you'll get bad growths on your trees, and it can kill them. So you got to be very careful of that. Some trees you're going to have to use straps. They may have limitations or restrictions against putting any hardware in those trees, so you have to use some straps. But when you can, use stainless steel hardware. That's what arborists use. And hanger bolts. Hanger bolts stand off the tree just a little bit, and they allow for growth, because trees, you have to be able to adjust these bolts depending on how fast this tree grows. It could be every season, or it could be every 2-3 years. You have to see how fast, because the tree, the way it grows, it's going to fill out and it's going to swallow your light fixture if you don't continue to move it out in service. So hanger bolts, where they'll screw into the tree, you can see it lit, and you got a little bit of standoff room. That's the best way to make sure you can ensure a little bit of long term before you have to go in and adjust those. Try not to, I shoot for about 30 feet for downlights. Moonlights, you're up 70, 80 feet. That's a different beast altogether. You're more ambience when you're doing moonlighting. But for downlighting, I try to keep it up about 30 feet, because if you look at a peripheral vision for where we see, about 25 feet above our peripheral vision, it kind of fades off. So if you can get that tree light up above that and have good glare control, you're probably not going to see it in most of what you're looking at. Sure, you can look up and see it, but as you're looking across the scene, that's going to be mostly up and out of your vision. So I try to go at least 30 feet or higher for most of your downlights, and then just use optics and your lumen outputs to match it. As you are installing those, for years I would climb up a ladder and I would sit here at my tree downlights and I would look and I would say, I think that's right, until I got smart and I got a laser. And I would set my laser now up on top of this body, I would shoot it, and I can aim down the length of that downlight, the whole body of that downlight, and I can actually aim that green laser where I want it to go. And most of the time, I don't have to do much adjustment after that. I'm hitting the spot where I need it to go. So just keep a cheap green laser you get from Amazon for rough aiming, and that'll minimize your ladder time as well too. And then using perforate shielding, you want to check for glare. And then underneath, when you're doing tree downlights, and this is it's an awesome effect. Anytime you can use the trees above you instead of path lights, it's always better, because anytime you can mount from above and minimize hardware on the ground, it's always better. Because you don't have to worry about frost heaving, you have to worry about knocking it over, getting it kicked and destroyed. It's always better. But one thing, when you're downlighting, when you're putting in the tree, sometimes you're going to have to do some pruning, because if you got branches right underneath it, one, it's going to block the light, and two, it's going to create a giant hot spot right up in the tree, be very distracting. So rule of thumb is you want to have clearance a good 5 to 7 feet underneath it. Clear out some branches, let that light open, and even if it's got branches there, now what will happen is it'll light down through that, and you'll have some dappled like leaf patterns and things on the ground, which is pretty attractive. It's fun. But you want to be careful about that downlight. So as they're coming in, cable runs. Your techs are going to start running your cables to the transformers. For cable installation, I look at 5 to 6 feet deep, or 5 to 6 inches minimum. 6 feet deep, that would be terrible. And then I group and tape my home runs together. So as you're putting up against a foundation, if you're doing architectural lighting, up against a foundation is a great way to put it, because nobody's going to be digging flowers there. So you can take all your home runs, bundle them up. You can zip tie them. I use electrical tape or whatever. Put them up against that foundation, bury them, and they'll be out of the way pretty well. Some of the things you need to watch for if you're coming across like flower beds, put them in conduit in those sections, because they're going to active digging areas. They'll cut it. You don't want to deal with that, and especially in transition zones between a plant bed and a grass area. Those weed edgers are going to come in with a hard weed edger, and so schedule-80 conduit, even if it's just a small piece, put it down in between in that section, run your wire through it, and you don't have to worry about it being cut by a weed edger. So just small little things you can see, placing a transition down there. Stapling everything down is very important. We talked about running the cable in the trees. Again, look at concealing your wire on the least visible side of the tree where nobody's going to look. Don't run it right down to the main point of view where people are going to see it. Run it down through the back. Again, you're using stainless steel hardware, stainless steel screws. And then what we found to be very effective is using zip ties that have the little holes in the end. And just putting those in, zip tie your wire, and it allows it to float off that tree. And as that tree grows, if you don't get to it in time, what will happen is that tree will just push that cable right off that zip tie, and then it's not going to eat it up. So very, very, very important to make sure you have some flexibility on that if you don't get to it in time. There's no need to leave excess wire at the base of a tree. People think that, as the tree grows, I need to leave excess wire so the tree can grow up. That's not how trees grow. Trees grow by apical dominance. They grow from the tips. They just continue to grow up. They never grow from the base. They just get wider is what they do. So you're never going to see a tree actually pulling wire up a tree. That's not how trees grow. So that's just kind of a rule of thumb, so you know. So you don't necessarily need to leave it there at the base. Okay, so now that you got your wire in the ground, everybody's got your fixtures placed, now you start making connections. So while my Tech 2 is out in the field making connections, my Tech 1, he's going to be back, and he's going to be wiring up the transformer, getting all the home runs put up in there. For the transformers, you should be using a transformer with lugs that you can put 2 to 3 12-2 wires in there comfortably into those lugs. Using UL all-weathered cable, obviously, in there, stripping 1/2 to 3/4 inch. And you want to make sure you're loading and balancing your transformer carefully, especially if you have, like you can see here, we have 2 circuits. That's a 600-watt transformer typically. And you want to make sure that you're splitting your loads between the 2 sides as evenly as you can. Don't put everything on one side and leave the other one empty. Even if you're planning to do more later, split those loads and load and balance your transformer evenly, because inside that transformer, there's actually 2 transformers in there. And they're stacked, they're encapsulated separately, and each circuit is running to each one of those transformers. So as you're pulling those circuits, just balance, load and balancing your transformers as equally as you can. And then for sure, once everything's done, you need to test it. So for record documents, understanding what you installed, how it went together, check your voltage tap outputs, make sure that they're rating right. Check your amp loads on each of the secondary low voltage wires. So you're going to amp clamp it. You're going to see how many amps it's pulling on the secondary cable on the landscape side. And then check the total amp load on the 120 volt side. You'll have a service test loop in your transformer. Clamp that and check and make sure against what you recorded on the main circuit at the panel for capacity, what you have left. Just make sure you're right about where you needed to be and you're not going to exceed that 80% on that. So that's very important. And then I always test the fixture closest to the transformer on each circuit run, closest to the transformer and furthest away, just making sure I'm within the proper voltage range, which we'll talk about more here in just a couple minutes. Clean up, backfill the trenches, obviously. Clean the site. Don't rush this. I see guys that rush through the cleaning and leave a mess. Even our techs have done it sometimes. I'm like, dude, what are you doing? This is what people remember you for. If you can't do the 1% right at the very end, they remember you for that stuff. And then very, very important, make sure your tech is available to go through and do night aimings. Just installing lights isn't enough. You got to be there to aim the lights. That's a very younger version of me. So tech one, use your lead tech. If you're going to need to go out and aim in trees and move things around, you don't want the designer doing that, because once he's out there moving lights around, he's going to look into that light source. He's going to be blind for 10, 20 minutes. His perception of vision is going to be off. And he needs to be able to stand back and look at those luminance levels and balance those things. So that's what your tech one comes in and does. He's adding, shields. He's moving shields around. He might be moving that fixture here and there. He might be dimming the fixture down and get it right for you. The designer's standing back and just balancing all those loads. So that's what your tech one is out there to do and help you get through that for your walkthrough. So some of the installation tools, you probably have a lot of these tools already. There's a few special ones that you might need for landscape lighting. And if you guys want a list of tools that you need, I've got a complete tool list that I outfit our new locations with. It gives you everything from power tools, hand tools, everything that you need, specialty tools just for landscaping and landscape lighting. So if you wanted that list, I'm not going to go through it now, but if you're interested, come up with me afterwards. I'll get your information and I will email you that list so you have it. And then you need mobile inventory as well too. So as you're going out and installing, as it always happens, John knows, we go out, customer goes, hey, this is great, let's add a little more here. And you don't want to make another trip back. So keeping some inventory of some of the basic staples, spotlights, path lights, some of the various things that you need. Keep a few on board. Maybe keep an extra power center, keep a few extra rolls of cable, extra lamps if you're doing lamp type of LED technology or whatever your power modules are. Connectors, consumables, right? Nuts, screws, bolts, all those things that you need from a daily basis. Just keep an excess on hand so you have it. Running lots of trips to Home Depot kills your efficiency. Okay? Relevant trade skills to know. General landscaping. If you don't know much about general landscaping, understand how paver systems go together, block systems, segmental block systems. Understand trees, arboriculture, understand pruning. Many times we light trees, they need to be pruned. If you're not comfortable with it, hire an arborist to do that, to come out. So because you need to open up those canopies of those trees inside to let the light move through. Some are just scrubbing you like, this is ugly, I don't want to light that. So understanding that. Doing some masonry, knowing how to do mortar work, wood and finished carpentry. When you're a lighting guy, you're a jack of all trades. You need to know a little bit of everything and how to make it happen, or you got to have good trade partners that are really good that you can count on to come in and help you. Okay, let's look at power systems, controls and voltage management. Let's start here looking at some transformers. Now, transformers themselves, you guys may know this, but transformers are nothing. They're not complicated. They're just reducers. And all they're doing, it's a 10-to-1 ratio. They're taking line voltage power, they're reducing it 10 times down into a low voltage spectrum. So if you have a 120 volt system, what you got, it's knocking it down to 12 volts. It's just reducers. That's simply all it is. And they work very, very simply. This is a laminated core transformer. And all it is, you have the wires never touch. The primary side, and primary I'm talking about 120 volt, and the secondary side is the low volt side. But the wires never actually touch. What you have is you have a magnetic flux field that translates power from the primary side to the secondary side through magnetic energy. Because you've energized that 120 volt side, you have 10 times the windings. There's more power there. As that magnetic field moves through, the limited number of windings, it's only going to accept 1/10 the power. That's how you have that step down of power. And you have that isolation between the two sides. They operate at 60 hertz and it's a sine wave. So every time that sine wave goes up and down, between the up and the down, over a minute, that's how you get your 120 volt AC, right? You have toroidal cores. It's a different type of a transformer, but it does the same thing, right? The beauty of toroidal cores, they're a little bit lighter. They run a little bit quieter. They don't have the hum sometimes when you load them up. Sometimes you'll hear a vibration with transformers. That's usually in a laminated core. Toroidal cores run much quieter, and they're usually more compact in size. Transformer types, you have on the left, you have the typical type you would hang on a wall, multi-tap, and then you've got in-grades, grounding base. So that's a Q-Tran Q-Volt that you would bury out in the landscape somewhere. Okay. I think we covered this in transformers already when we talked about it a little bit earlier. So let's talk about some basic lighting controls. I mean, most outdoor lighting, it's not overly complicated. But some of the basic things, you may not need a super complicated lighting control system. Some people, when we're designing our lighting, we're not necessarily designing in multiple zones. Sometimes we are, but generally we're looking at setting light levels so that everything is part of one general scene when people are looking out. And if we start pulling zones out, it diminishes the whole scene and the creativity and the art of it all. And so most of our clients, I would say majority of our clients, just want simple controls. They want it all on, all off. And there are some things you have to be aware of. You do have some dark sky considerations in some areas. Phenology, with plant material, there are some like fine needled evergreens, spruce, fir, true cedars, fine needles. They don't like light all night. And if you leave those on, you'll actually kill the tree. They'll defoliate over year 1, year 2, and they'll be completely dead. You'll see a bunch of dead spruce trees you'll have to pull out. And I've documented that over the last 8-9 years where we've seen that those trees are very susceptible. They need time to sleep. It's okay, light them for the first part of the night, but when you go to bed, let them go to bed because they need that darkness, at least in that species. Some are much more resilient, but the fine needle conifers, they really need that time to sleep. So that's where you might want to zone some of those areas and have some of those shut off. Even think about birds and insects. A lot of the plant material that we have around our house, there's birds nesting in there. I don't want to sit under a spotlight all night. They don't either. So yeah, let them sleep. It's always good practice, right? Let your landscape sleep when you go to bed as well too. So your neighbors will probably also appreciate that. But photocells, they're very basic. Dusk to dawn. It's the least service intense option. Rarely things go wrong with those. The second best, you might go to an astronomic timer. So this is what I usually use if I want to have an off time, say at midnight, 1 o'clock. It'll run dusk to dawn. It adjusts automatically for the sunrise sunset schedules based off your latitude and longitude. Plug it in, set your time, and you can set your off times, and it adjusts every day about 30 seconds. So very handy, very simple to use and program. And then you have another thing called a sequencer. So if you want to have multiple transformers linked to one controller, you could have a bank of transformers or different parts of the yard. And what a sequencer will do is you put it in the basically in a slave transformer. Your master transformer is going to have either your photocell or it's going to have your timer. And out in the field, you'll have other transformers that you want to sync together. And so what a sequencer does, you would plug your just a control wire from another part of a system, bring it over, hook it in, and so when the master kicks on, it's going to automatically sequence those transformers, send the signal to turn on, and it'll power everything together. So kind of an old school. You don't see a whole lot of them anymore, but it's something you will see out there as you start getting into the landscape lighting industry.
So where do you put the controller if you want to do zones?
So that's where I'm going to right now. So this is going to be the next one. So an automated zone controller. A lot of you guys are looking at products out here, manufacturers that have their own proprietary technology, their API, they're using their own apps, controlling it. That's great, but sometimes the client doesn't want to go search for another app, and sometimes the UIs and the APIs get a little clunky trying to use them. There's actually third-party products out there, like this one here called Let's Go products. It's an automated zone controller. As you are running your control cables through your system, this is great if it's especially new construction, you can run your control cables to this and you have 3 individual zones, 300 watt zones that you can run through. And you can control them from any control system you want, whether it's Lutron, Crestron, it's brand agnostic. It doesn't matter because it's pulse technology and you can control it right from the main panel along with everything else, set your scenes. And it wires in on the secondary side of the transformer. So basically all the zones that come out of your transformer, they run into this, and this is what tells those zones to turn on, dim, control it at certain times. So you have to still wire those zones accordingly, but it gives you more control to do it if you don't necessarily want to have to go use a brand A or brand B that has their proprietary technology. This gives you much more freedom to use any brand that you want. So zoning and dimming is built in. Okay, any questions on that so far? All right, I'm going to talk fast. You guys are listening fast, so this is great. All right, let's talk about voltage drop and low voltage systems. You guys know much about that or had to deal with that? I'm sure you probably have dealing with cables, right? So obviously we know that the primary factors for voltage loss in low voltage systems, obviously there's not a lot of current as we're pushing that through there. So things that, it's a factor of 3, and I look at this as a factor of load, that's your wattage, right? The distance that has to travel and how big your highway is to get it there, right? Like this guy here, he's got a big load, he's got a way to go, he might be a little slow, right? So he's gonna have some trouble. But secondary factors can also be the type of connection that you're using. Some connections can come loose. can cause an increase in current and can cause some problems. You can have some cable integrity, something might get damaged, or the primary voltage might take a nosedive, and that's going to affect the secondary voltage on your transformer as well too. So just understanding some of those things, how it affects voltage. So you guys are probably all familiar with Ohm's law as well too, right? Dealing with power, right? Voltage, amperage, and ohms. Obviously voltage, that's the pressure, that's what's pushing your amperage, your current through the lines. But if you get some resistance in there, which could be a cut in a wire, it could be a bad connection, that's going to crimp it down and that's going to keep your voltage from passing through. And I look at it like a water hose, right? That analogy. If you have problems down the line in that pipe or in the cable, you're gonna affect your voltage down the line. So basic power terms, you know, I don't think I probably need to go through this, but a watt, it's a measure of power, a radiant flux. A volt, obviously that's the pressure that's pushing through the line. Obviously the higher voltage, the more pressure there is. And an amp is simply just a unit of measure of electrical current. That's all it is. And so this is going to be interesting. So a voltage drop formula that you see here, this is something that you'll want to know if you're going to try and calculate in your pre-planning for your installation what you might typically encounter, or you know, if you have a certain number of watts that you're going to put out there, what kind of voltage drop am I going to encounter? Do I need to go to a heavier gauge cable, or can I handle with this 12? Worst thing is putting it all together, putting it in the ground and finding that, uh-oh, I didn't do my voltage calculations and now I need to run another wire, or I have to split that load and take some lights off. So just do your pre-planning. So a real simple formula is going to be your true watts, so that's the total watts you're adding for all the voltage you're using, times the length of the cable, so from your transformer all the way out to your, probably your last fixture. And then you also want to divided by your cable constant. So your cable constant is what's given by manufacturers. It basically, it indicates the thickness of the copper wire, and the greater the number of copper strands that you have, obviously, the better capacity for carrying current down through there without loss. So each manufacturer lists these out, and so if we wanted to look at one example, if we had 100 watts of fixtures and 100 feet away from that power center, what we do is we take that formula, watts times length, 100 watts times 100 feet gives you 10,000. You take that 10,000, you divide it by the cable constant for 12 gauge, 7,500. And that gives you a voltage drop of 1.33, but because this is AC current, it's coming out and back, we have to multiply that by 2, so that gives us a 2.66 volt power drop. And what we do now is we take the voltage of the transformer, and basically we add that 2.66 to it, and that tells us what tap we need to put them on. In a multi-tap transformer, we'll have a 12, 13, 14, 15 volt tap, and we use those output voltage taps to counteract that voltage drop. In the old days of halogen, we had a really narrow window. It was 10.8 to 11.5 volts, so we had to get those light bulbs in, otherwise they'd burn out prematurely, or you know, you'd have a bad tungsten would coat the insides of the bulbs. LEDs are much more forgiving now, but what we're finding is that now that LEDs are getting higher and higher powered with higher VA ratings, we're finding that now we're starting to have issues where people don't understand voltage drop, they're not calculating for it, and now when you kick that power on, you're getting a disco show and people don't know why, because now that power is plummeted, they don't have enough power to operate those LEDs, and they just flash. So understanding voltage drop, knowing these formulas, very, very important pre-planning to make sure that you're accommodating enough cable. And if you're planning on adding more into that run, oversize your cable. It's better to have it and not need it than need it and not have it. Okay, let's talk about cables themselves. So talking about primary circuit cables and secondary circuit cables, you never want to, for a primary, I'm talking about a main circuit from a transformer out to a group of fixtures. Now, cable is rated for certain amperage ratings, and you should always have your primary circuit cable match the amperage rating of your transformer. If you undersize it, you may have trouble having, if you ever have a fault, your transformer may not trip. The breaker in there, the magnetic breaker may not trip. So you need to make sure that your primary cable at least matches the voltage rating of that circuit. In most landscape lighting circuits is going to be 25 amps. I think it's 25 amps on the secondary side. So never use a 14, 16, or 18. Those are secondary that you're going to see from a fixture lead, short, coming back to a hub connection, or back to the primary circuit. You always want to make sure and you would anyway, you'd want to use a heavier circuit to make sure you're carrying that load out. Most common is 12 gauge with LEDs. You have a voltage range usually between 12 to 15 volts on most of those. You want to keep them as close as you can to 12 to 13 as you can, but they do have a pretty wide range, so they're pretty forgiving. But rule of thumb, don't ever use like a 14 to go out and run your home run circuits on a 20, 25 amp circuit. You're just asking for trouble. Common types of cable that are used, obviously the LVL, the standard low voltage lighting cable, is direct burial, it's UV stabilized, and it's super flexible. We use a stranded cable because you could use solid core cable like you use in the house, like Romex, but you try to put that out in a landscape, it's stiff, you never want to use that. The beauty of landscape cable with this multi-strand, it allows us to move with the landscape. It's flexible through the seasons, and that's what makes it so handy for us. The THHN, again, it's a stranded cable, but it comes in individual colors. It's not direct burial. But if you're doing conduit, you're running conduit everywhere in your installation as opposed to direct burial, it's so much easier to pull. Between the shielding of it, pulling single strands for corners and bends in conduit in 90s, THHN is the best way to go to run your circuit cables. And then you have obviously submersible pump cable. You're going to see this type of cable coming out of underwater fixtures or some hardscape fixtures where they almost have a pool gland where they're sealed up inside. You're going to have that round jacket. Inside that, what we recommend is on the ends of those, seal them up with a heat shrink, adhesive line heat shrink, so water can't go up because you're going to get a vacuum effect. As if you don't seal up those ends, you can get a vacuum effect in your well lights or in your underwater lights. As they heat up during the night, the pressure will increase, and then as they turn off, they cool down, the vacuum, it'll pull air into that fixture. And if you have that open end, open to the dirt or wet soils, it's gonna pull moisture right up that line, and you'll see moisture inside. Most of the time you see well lights or in-grade lights that have water in them, it's not from leaking, it's from not sealing off those ends of those cables very well. So MC cable, obviously we don't use it a whole lot if you're gonna do anything inside a structure. Or particularly commercial. If you're running adjacent with audio, you need to shield it so the signals doesn't mess up your audio signal. So a couple different ones there. Proper connections. Never, ever, 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 I don't know, this is just me, don't ever use a wire net. Wire nets were made for solid stranded cable. They have teeth that cut into Romex, hard cable. We're using flexible cable. So use something that's gonna grab. So we usually use like a copper Buchanan crimp with a 4-way crimp. And you crimp those things down. You need strain relief because you're gonna have roots, you're gonna have things that are gonna grow, and they're gonna put strain on those cables sometimes, in those connections. And if you're using wire nets, they're just gonna pull them apart, and you're gonna start getting high current because those connections are loose. You can burn some of your wiring in the landscape, you can start a fire. So we typically like to use, if it's going in the ground, crimp that thing, put it in a high temp grease tube, because it's fast. Again, this is speed, getting through the project. If it's above ground, we like adhesive line heat shrink with the same crimps. And adhesive line is not regular heat shrink. It actually has a glue on the inside that as you heat it, it melts and it moves to the outside and it waterproofs and seals that connection. And those are great if you're going to be putting anything that's visible on the outside where it still needs to have a watertight connection. So a little bit cleaner all the way through there. And there's several brands. Light Shrink is a great one that we use for those types of products. This is why I try not to use the wrong connections. Wire nets, eventually they're going to fail. They're going to move in the dirt as the soil moves. It's going to loosen up the connections in there. You can see them burn. Obviously, pierce point connections, that's my hand there. You can see I've come up and seen some just terrible things. I've seen mulch on fire, smoldering. It's just, they're not good connections. Connections are the weak point in all of your system. With conduit installations, obviously it's the superior protection, but it's much more labor intense, it's much more disruptive to your landscape, and you need to charge a heck of a lot more for it. But it's great to install because your service calls from people cutting the wire, rarely ever gonna happen. One thing I will say is lightning and surge arrest protection. We started doing this, our sister company created a class 1 surge protection device. It's the only one on the market. It will take an 80,000 volt strike. Same thing you would put in a whole home surge protection, but we adapted it to the low voltage lighting system simply because you look at a low voltage system, usually what they're doing, static electricity is looking for tall trees, it's looking for a way down to the ground, water near a lake. You've created, with all this copper wire, you've created a giant antenna, and it all leads right back to the house, all the components inside the house. And so what we do is we'll actually use an 8-foot ground rod with each one of these surge protection devices at a hub connection in a main circuit. And anything that comes down a tree, especially at the bottom of a tree where there's downlights in the tree or at the edge of water or open places where we think there could be a strike, we place multiples of these out there, And anything that comes into that property, it goes directly to ground before it ever comes back to the components in the house, because that's the worst thing that could possibly happen. And most strikes are happening in trees and areas around it, and they're coming in and affecting the house. So we do everything we can to shunt that out in the system and also preserve the landscape lighting system. So very important things to look at. All right, we got just a few minutes here left. I'm going to run through the types of fixtures that you're going to get into, and this is no particular brand, but we're going to take a look at directional spotlights. This is the ubiquitous uplight that most people see. This is ultimate versatility, a high degree of adjustability. They're usually small, compact, but you can use them for uplighting, trees, architecture, statuary, general illumination. They're kind of the jack of all trades fixture. And again, these are just basic brass fixtures that you'll see out there, but you'll have different sizes. So this is kind of like a medium-sized spotlight. If you're using LED lamps, you'd use an MR16, or you could use a module-based type of product as well. But you're looking at like 150 to 500 lumens, and this, again, it's kind of a jack of all trades. You'll get into something like a little mini spot, might use an MR11 or a module. These are going to be smaller, 125 to 100 to 250 lumens. These are lower output. These are great for smaller accents, or maybe putting up on a second floor to illuminate dormers. Always a great place. And then you got large spots, and again, this is, could be a par 36 or it could be a large module. 550 lumens to 2,000 lumens. We can crank out a lot of power if needed. Rarely do we need that much, but if you really got to reach up into some tall trees, you can do it. In-grade lights are still considered uplights, right? So you can use something like a mini or a niche light. There's a lot of manufacturers that make really small little niche lights. You can use them horizontally, like in this particular application, or you can use them underneath pots, ingrate them on the edges of walkways, all kinds of things you can use for marker lights. Medium grade uplights, great for architecture where you don't have the ability to put a stake in the ground. So you're coming out, you're core drilling, you're running cable underneath concrete, and you're inserting those lights to work like you would with a stake mount. And then even for high output, much like that high output light where you're getting 550 to 2,000 lumens, big trees, but it's in grass, obviously you're not going to put a spotlight out there, it's going to get destroyed. So you put something that lawn equipment can safely go over the top of. All right, directional wash lights. Again, these are very much, again, stake, they're uplight, but a wash light is much more gentle, so small walls, statuary, short hedges, they're great for that. Low output. Large wash lights, you can use them on architecture because you're usually going to have softer beam spreads, especially on light colored architecture where you don't want a lot of beam artifacts. Always a good way to go with that. Path and area lights, so you've got the ubiquitous cap and stick. You see a lot of those around, a lot of different hat options. So again, you could have modules, you could have G4 bipins, tall area lights, right? You could have tikis, things that are 5-6 feet high. One thing we recommend with these is they're a huge cantilever. They're great for around pools and pool decks where you need a wide area light, but just be careful because people bump them. And what we recommend is don't use the plastic stake that comes with them. Put in 18 to 24 inches of extra risers in there and put them in concrete because that'll stiffen everything up and they're not going to get knocked over and broken because that always happens. Deck and hardscape lights, so putting lights in posts. And I'm looking at, obviously alternatives where you're not going to use a path light. You need to get light on a surface where people are moving around and walking. That's a great alternative to come in, and there's tons of different varieties and choices of styles. Hardscape lights, putting them underneath masonry caps where, again, people are moving around a place where it's all hardscape, has seat walls. That's a great way to add illumination and safety to those spaces. You have wall sconces you can put on fences. Some of them are just downlight sconces, and you have some that are up-down sconces that you can actually do some uplighting with and downlighting with together. So different varieties of sconces you can use. You can even have some little mini ones that you can actually around pools where they have the aluminum fences. You can actually integrate those into the posts around. And it's probably dark in here. You guys probably can't even see that. I'm sorry. You can integrate those into the posts where you just run the wire at the base, dig out, and just fish the wire up to the top of that aluminum post, and you've got great little light right there. Real skinny little lights. And it's a great way to keep light from getting damaged, but illuminate those hard places. Down and wall lighting, down lighting of course, anything about 30 feet and above. Directional lights, these are great if you don't want to put hardware path lights on the ground, but you need to illuminate elevation changes. Downlights are great for that. Get up above if you have the trees. I'm always looking when I'm coming out surveying a site. First thing I look at is I'm looking where people are going to walk. I lift my head. I'm always looking, are there trees overhead where I can mount lights? Whether it be a downlight, whether it be something for moonlight, where you just need an ambiance that are going to go 70, 80 feet up into a tree just to create a general mood. It could be a fixed downlight where you're using something off of a pergola or porch where it's fixed and downlighting with maybe a little orbital mount so you can have some slight adjustments. It could be a ring mount or a pendant. And these are great where the tree may be too small to actually have a fixed downlight in where you're going to put screws in it. With a pendant, you can come out over a limb, they're very light, and you can come out over a table or a piece of art or maybe over a water feature and use that limb, mount to it, and just hang that pendant right over those spots in free space. And so they're very effective tool to be able to do that. Obviously recessed lights. Most of the ones we use in the low volt side, they're very low output. Again, up down sconces, down sconces with more power. Underwater lighting, so you've got higher power underwater lighting. We typically like to put lighting directly underneath the water flow itself so you can see that action. Or small little niche lights you actually put in the bowl so you see the water dancing and get them inside so you get that. That's part of my lighting design class, putting them inside. That gives you that ability. You've got decorative path lights and bollards, so this is a nightscaping product that's really cool. It's different. If you don't like the typical cap and stick, you can go with something like a little 2x2, something decorative to put on a pathway that's unique, has neat shadow patterns. And those come in different sizes. They have accessory tops, which are kind of fun. Bird baths in the garden, planters, you can add to those. A tiki top, mailboxes. Yeah, you adapt a lot of things to it, right? Even audio. There's an audio base even around pools. So a lot of options. It's a cool nightscaping product. They're actually, not supposed to say anything, booth 1048, kind of pretty cool. I love those projects. So definitely ways to do it. So just wrapping this up here, the very last thing is cleanup and detail of your system. So when you're done with your system, the number one thing is just clean them up. So your fixtures, number one, when you're working and put them in the ground, they're gonna get dirty. Take a little WD-40, get a rag, just wipe them down, get them clean, and get the mulch nice and settled underneath it. Just detail it out nicely. If you're not a landscaper, just practice with it, rake everything smooth, and those finished details are gonna make a big difference. Trash roundup, even if it's not my trash, I tell my guys, pick it up, just clean it up. Just leave the place better than when you found it, just so I want a referral from this customer. And if there's any one little thing that's lingering, like, oh, the light looks great, but man, they left a mess. My sidewalk's all dirty, they didn't clean the mud off. That stuff, man, it matters. So just go through, do a really good cleanup. Clean your fixtures, make sure your wires are buried. Make sure that you have recorded all the information you need for your record documents so that when you're coming back, you need to provide that because you're not always gonna be the one out there. You may have a service tech that was never on that site. Make sure you have that documentation so he knows when he goes out and checks, he can check those voltages at the transformer. He can see if something has changed. He can see what kind of capacities we have left on those circuits if you ever want to add. So just make sure you're taking that record document, get a copy to the owner, and keep one for yourself on file as well too. And then that just goes into making sure you're doing your as-built. A lot of guys don't do as-built. It's important to know where your wires are run, what was recorded, how the system was built. All the circuits, the power feeds, all the readings, what surge devices were put in there, where do you cross underneath hardscape areas like sidewalks, driveways. Just got to note all that so people know if they ever have to get back into it again. What type of fixtures were used, so that if you ever have to replace one, you can just look at the schedule and you can go, oh, okay, it was this fixture, this wattage, this beam thread, this CCT, order it, put it in, replace it. You don't have to make a trip to the site to go, what was this? And then go back and reorder. So it just saves time. Preventive maintenance, don't overlook this. This is a cash, a way for you guys to infuse cash into your operation. And it also helps maintain a relationship with your client. Landscape lighting, anything outside, if it's not maintained, it's gonna fall apart. Even if it's the best, can be the best components, but if you're not touching it and maintaining it and cleaning it, things are gonna happen. Plants are gonna overgrow it, it's gonna block the light, so it's not gonna look good. So we recommend at a very, very minimum, at least once a year, but I say at least twice a year. And on big estates where you've got, high lux estates where you've got 5, 6, 7, up to 1,000 fixtures, you're probably gonna wanna go about every month or two and just build that. They're not gonna care the price, you bill it out monthly. And this is great for cash flow for you guys because in service, it's just simple. It's cleaning, it's adjusting the screws back out of the trees, looking for buried wire, anything that happens through there, looking for burnouts. you're just making sure that the system always looks its best, and discriminating clients, they really appreciate that. They just want it to work. They don't want to worry about calling you if something goes out. It's a great revenue source for you. And I tell my techs, anytime you go out to do a service call and you're getting FaceTime with that client, look for areas where you can upgrade. Maybe it's a new product or a new service, or maybe it's something that wasn't added in a particular phase. Hey, maybe they're ready for it now. Hey, let's add these trees. Let's add this into this section over here that maybe wasn't part of the original plan, but maybe they're ready for it now. So that's always really a good part of it. So any questions? Either I did a good job or I've totally gone over everybody's head. I don't know.
I didn't see any color lights in your slides. Is there a reason for that?
Yes, absolutely. There's a very good reason for that. Color lights are a gimmick. If a designer doesn't know how to design with variable colors of white CCT, they probably shouldn't be designing. Color should be used not to bathe everything, especially in a residential property. Good designers know there's enough color present in landscape materials, trees, boulders, shrubs. Use the appropriate CCT. Blend your CCT colors, the colors of white, 2700K to 4000, 5700. Use those colors more effectively, because if you do that, color, now I'm not saying there's not a place for our full color spectrum lights or RGB, but you use those subtly as an accent. You don't use it to overpower the white lighting in the control of the landscape. Otherwise, it dominates the scene of the landscape that's there. It overpowers it, and it ruins the narrative. Can it be used? Absolutely. If you know how, what I recommend you guys, if you really want to understand lighting design, study theatrical lighting and study movies. Study the color science between the colors of the scenes that they use, between the backgrounds, the cyan, the magenta, the different colors that they mix in there, because that will help you understand how to use color effectively in a landscape. And don't just wash everything like a bag of Skittles throwing up, because that's the absolute worst thing you can do for a client, because it makes the spaces really uncomfortable over time. Warm white is naturally, it helps our melatonin levels as we're out at night. You start mixing these other colors in there, it makes, naturally, our natural systems, it puts us on edge. Now, I'm not saying for party mode, for party mode, pull your color on if you want. But one of the downsides of those RGBW fixtures is when they try to mix white back into it with their LED mix, it does a really crappy job. It's very low CRI, it's not very good quality light. And the only thing that matters, it's not the fixture, it's not the brass. All that is a lamp holder. The only thing that matters in your design is the light source, the quality of the light source, because your fixture is not lighting your home, it's not lighting your trees, it's the LED. And if your light source sucks, your lighting is going to suck. That's why I say,
Coastal Source Lutron lights?
we install Coastal Source, yeah. So, yep, they've got some great products. When you're talking about full color RGB, just be careful with it, how you use it. It can get a little gaudy, and just use it. If you use it as an accent. Like even in the fall, like maybe you have a particular tree, a Japanese maple that goes from green to orange. Don't go full orange on the light because the color is already there, but maybe go a slight amber or a slight pink, and that'll just accentuate the colors that are there already without dominating the color that's in the tree. Just use it to accent the colors that are there. Because color, in one of my other talks, it's about the emotive power of light. Light is so powerful, and the colors that we use in that, it completely changes your emotions and how you feel in a space. Whether it's cool or cold or warm, and how we mix those colors, it's so incredibly important. And you guys, as designers, you have no idea how much power you have to create the mood and emotions and the feelings of people's in these spaces just by how you craft that color mix in that space. It'll make you a better designer. Don't do everything in one color because it's just kind of monochromatic, but understanding how that goes together, you can layer those things. Like, for example, 20, you guys can leave if you want, but 2700 Kelvin, it's higher in the red-orange spectrum. So typically things that are orange, buff-colored, sandstone, typically take that color light better. But green trees and things like that, they can get a little muddy. So if you shift up to like a 3000, you're going to have a higher green-blue spectrum in that light spectrum, in that LED, and it's going to reflect the light off of what's naturally in those objects much better, much cleaner. Even bumping up, if you want to have even more of an accent, think about conifers, maybe in a few areas as an accent or to draw your eye, maybe something like a 4000 Kelvin, and just pop that color a little bit more. The higher you go in the range, the higher it spikes in the blue-green spectrum, and it'll look a little more natural on plant material as opposed to washing it out. So, But that's another design class altogether. You spend a lot of time on that as well. But really focused on the installation side. I hope it was a help to you guys. I really do. Any other questions I can answer for you, John?
I got one more comment. Well, I guess it's a question. I guess it's a leading question. The question is, are there any organizations that we can join or any trainings that we can get that helps us out with design and installation?
John, I'm so glad you asked that. So yes, two of the organizations that I'm involved with, actually John is involved with as well too, as leading question. If you really want to learn to see light, I mean really understand, instead of just lighting objects, understand composition, understand the nuances of light when you're looking from perspective, I highly recommend the International Landscape Lighting Institute. It was founded by Jan Moyer. She is a lighting artist extraordinaire. She's done projects all over the world. It's iliedu.org, International Landscape Lighting Institute. They have a 5-day boot camp between, it's a class session and it's in the field. You are actually using products out there, different products from different manufacturers, and you have some of the best designers in the world out there mentoring you in those teams, working together to show you what is really possible. If you have an unlimited budget, unlimited number of fixtures, what can I do? And that's what you can explore, right? We rarely get those opportunities. And you will learn so much about light in that because it really deals with the conceptual lighting design, which is the most important step of lighting design in the conceptual side. Other organizations, the Association of Outdoor Lighting Professionals, if you really want to get involved in the landscape lighting business, you're going to network with professionals from all over the country, hundreds and hundreds of professionals that have been doing this for years. The networking opportunities, the knowledge that is shared about how to run your business, how to set things up. They have certified outdoor lighting design courses, certified low voltage lighting technician. If you have techs you want to install, that want to install for you, send them this course, get them certified, teach them how to do it the right way, and they will be your best asset. So AOLP, Association of Outdoor Lighting Professionals, International Landscape Lighting Institute. Thank you, John.
Thank you for that answer. That's a great answer.
So great place to go to learn. All right, you guys have been great. Yeah, one more question back.
So with coastal source, they have their proprietary cabling. Does that make you nervous?
You just have to be careful with it. So like we crimp all of ours. I'm not saying it's a bad connection. It's very watertight. So when you're using it, you just have to make sure, especially around trees, because it is just a plastic thread. What will happen is if you get it around trees and as tree roots grow, if it doesn't get maintained, you'll get strain, and what it'll do is it'll actually pop that thing apart because it's not really physically connected. You're putting two pins together and using a plastic, plastic threads to screw it together. So just be careful about how you use them. If you're going to put them around a tree, put them outside the drip line. Keep them away from those if you're going to use that type of a connection system. As opposed to, if you're crimping things with a Buchanan crimp, they can take a whole lot more. It'll dig into the tree before it pulls that connection apart. Good question, though. Thank you. Anyone else? Guys, you've been awesome. I hope it was helpful. I hope you learned something. And if you'd like any more information, I have some cards. You're welcome to stop by my booth, 4138 Lighthouse Design Studio. We'd be happy to give you more information. I'm always open for questions. Whether I'm working with you or not, or you just have general questions about lighting, I'm all about lighting education. That's why I'm involved with all these associations. I'm happy to help you guys get on the way, because I would rather you learn the right way and do it right and avoid the pitfalls that cost a lot of money in your business.